So make sure to go into the syllabus section and you can analyze what your grade is estimated to be at this point by looking at the section of the syllabus that breaks down the rubric. Effectively all you have to do is add up everything, divide it by the total amount, and then you'll find your mean. And then you add together all of your points, and then, it's cut into separate sections. So since we've already covered this on the first day of classes, if you want to review and see where you're sitting at, then go ahead and go into the syllabus and find the rubric and then perform that addition. And let's see. So I made a list of notes I wanted to go ahead and list out to everybody here regarding the lab notebook. So firstly, make sure whenever you turn it in, and this goes for anything, whether it be the quiz, the lab notebook, anything that you have to turn in online, always double check your upload, because I had more than a handful of people upload the wrong thing or not upload something. And so, the weeks that passed, we had a lot of stuff going on during the semester, and I totally understand. I'm being patient towards it. But moving forward, I'm gonna have a zero tolerance policy for everything going forward. You need to just stick your head to the grindstone. Let's get through the rest of the semester and finish off strong. It looks like everyone's doing, pretty great so far on everything. I think the quizzes are a little bit harder, just because you don't have as much knowledge in the information. And the notebooks, everyone's doing, fantastic on that so far. Just make sure, once again, when you finish your quiz, if you have to upload something like a last question of the quiz, upload it in there. Or if it's the lab notebook, double check when you upload something that you upload the right thing. And so that way that you get your full credit. So like I said, again, going forward, I'm going to be more strict. We have to grow from what we've learned in the semester. And, I'm lenient on the stuff in the past, but going forward, I'm not going to be so lenient. So secondly, okay, so within the notebook itself, in the purpose section, I had, a vast variety of people's different notebooks that they uploaded. So the ones that got, the really high scores, their purpose section, there's background information, there is the relative experiment, and then there's a sort of like a brief understanding of what we're doing this experiment for. So for instance, for the acid base extraction, you would get partial credit if you were explaining that you were going to be separating chemicals. But the main thing that you need to understand the purpose was to understand how to separate an acid and or base from a chemical solution using two-phase extraction. So, go into great detail with background and try and make like a paragraph purpose, 3 or 4 sentences of like a little background, and then a main focus of what we're doing, and then the final statement of what chemicals are we using, or something like that. It needs to be look like a paragraph. And some people who just did like a sentence, this week we're doing two-phase extraction, that's not enough. I won't give full credit for it. And going forward, I want to make sure that the main thing that everyone learns from this class is how to create a very strong notebook. And like I've said from week 1, you need to be able to walk into a lab with that notebook and be able to replicate the exact experiment to the T without having to use any outside materials. So that is kind of part of the purpose, is to understand why we are performing this. Secondly, I did notice some people still are having a misunderstanding of apparatus and instruments. And once again, we had covered that from the first few weeks. I no longer will be tolerating if people are messing that up. Apparatus is glassware, instruments are machines. We're really far down in the semester. So going forward, there will be no more tolerance for, getting the two mixed up. It'll just be points missed, unfortunately. And you just got to go from there. Apparatus is glassware, instruments are machines. And next, in the hazards, y'all are doing pretty good. I did notice some people missed a couple chemicals. So any chemicals that we use, any of them, other than I will dismiss soap and acetone unless they're within an experiment, like if you're using them. But since soap and acetone were just cleaning stuff, that's fine. I'm not going to take points off. But like we used the 3-nitroaniline, we used our benzoic acid, we used sodium hydroxide, we used hydrochloric acid. Those are all things that could possibly be, harmful. And some people will just miss like one thing here or there, and you will lose a point. The thing is that because everyone's doing such a good job on everything, that I want to be extremely critical and make sure that you understand that these things are dangerous. And since we're not performing these in lab, you have a lot more time to go work on the lab notebook. These these courses, or more to say, these Zoom sessions only take 30 minutes to an hour. So, utilize that extra time that you would have used in lab in order to create a really strong notebook, and understand that going forward into more advanced labs, that, having a strong notebook will give you, whenever a teacher looks at it and they see, oh my gosh, they've done everything from A to Z, there's no question. And then you get a great grade, you feel good, and you learned a lot from the class. So just make sure, list every single chemical other than soap and acetone, unless acetone is within a reaction. But in the case of like just cleaning up glassware with soap and acetone, that's fine. Going forward, the next thing is go through the lab manual. If you have to find the glassware size, make sure to just read through the lab manual very, very carefully. And I'll show you within the Sn1, Sn2 reaction we're going to review today, where exactly that is. So that way that you don't miss out on just a few points of, sizes of glassware, because once again, it is critical to know the size of the glassware we would be utilizing in lab. Then going forward, the conclusion section, the same thing as purpose. There was some of them were really good. Some of y'all went above and beyond, and I was like, great. Some people did multiple paragraphs, and I was like, wow, okay, great. But then others, some people, they'd have one or two sentences, and that's not going to be okay. Please look back at the syllabus. If you look at a section and it's like really short, go back to the syllabus and check it to see that you're not missing anything critical from it. The primary things that I'm more lenient on will be like changes to procedure, because we're not in the lab. If you're going to put something like, it was performed online, that's fine. Or if some sort of set of data is not given to you to perform the lab, you put that there too. I'm not too hypercritical on the changes of procedure, but the main things, you got to make sure you have a good purpose, good reason you're going into lab to perform this, and then a good conclusion to show me that you actually understood entirely. Not only, we recovered this many grams, we recovered this many grams, human error. Like, don't just like, retort what you have from your data. Understand it and explain exactly how, we pulled our amine from the organic layer, or how we pulled the benzoic acid from the organic layer, utilizing acid or base to do so. And just make sure that whenever you are ready to turn it in, just look back at your purpose section, look back at your conclusions, make sure it looks like a nice little paragraph. If you want to write a couple paragraphs, go ahead. If you want to go above and beyond, you're going to get the good grade. That's awesome. But if you feel like it's a little short, add in just a little touch of something. So that way, it adds more substance to the idea, not that it's just like a breeze through and you're just passing by the experiment and just getting out of lab as soon as possible. So the post-lab questions, I did notice that I'm having a little bit of trouble sometimes with some people, like about half of the people, they had put all of the post-lab questions and answers together. And then about the other half, it was just all the answers. So going forward, I'm going to make it a strict policy. I need everyone to put down your post-lab question and answer, question and answer, or put all the questions and all the answers. Do something where it shows the question and the answer, because I did notice that some people were just like answering things with little short statements. And if somebody were to look at your lab notebook and just see the post-lab answers, and they don't have full sentences or reasoning as to why this is here, then it's just, nonsensical. It's not really helpful for someone looking at your lab notebook. It's like, oh, okay, well, here's all these answers, but I have no clue what they're, I have no clue why it says benzoic acid here. I have no clue why it says recrystallization here. It's just like kind of ambiguous statements. So just for the sake of, refining everyone's lab notebook skills, let's go forward and just put the copy and paste the question in there. Just for the purpose section, or the procedure section, make sure that you are writing it out individual, like, you're rewording in your own words. But for the post-lab section, the post-lab questions, you can copy and paste it in. And, that's totally fine with me, because it's not plagiarism. You are answering the question to it. It is just that the procedure needs to be within your own words. And going forward with that, also just formatting, work on your formatting, make sure that your tables look nice. Make sure that if you start one section, that you don't immediately just jump to the next page. In that case, before you turn it in, hit enter, push it down to the next page and just start fresh. Keep the same font, the same sizes throughout, make it very, normal and legible. If you're writing, I'm not as critical about the, handwriting and such on that end, as long as it's legible. But if it is, you're typing it in Word, and then all of a sudden you started in, Times New Roman, and all of a sudden you're ending in Arials, and it's like shifting all this stuff, and one table's like the whole page, and then one table's really tiny. Just, work on formatting for the sake of, turning in future projects and more advanced labs that you might attend. And so one post-lab question I noticed that everyone had a little trouble on that I wanted to address for everybody is post-lab question number 4 in the acid-base extraction. And what happened was a lot of people were answering it saying that naphthalene would not be ionized because of resonance, making some of these claims that it seemed like that this went over everyone's head. And I wanted to address it because I saw that a good amount of people were using the phrase resonance or just neutral. But the idea is the reason it's non-ionizable is because it doesn't have a benzoic acid or an amine group attached to it. It is neutral because it has no functional groups that are ionizable. So the resonance factor, well, the contradictory point there is both 3-nitroaniline and benzoic acid both have resonance. They both have benzene rings. They all experience resonance. So that is a moot point. It's like saying it has carbon. It's like, well, all 3 of these compounds have carbon. That is not the point. The main point is that functional group, the important take-home point, and this might be on the final, so you might want to really understand from the acid-base techniques, is that if you have an amine group, then you can pull it out using an acid. If you have a benzoic acid group, you can pull it out using a base. That was the take-home point, and to me, I was a little worried, and that's why I'm addressing it right now, because that was like the biggest part of the experiment that everyone kind of just glided by. So when you're answering these post-lab questions, really take a look at what the questions are saying and try and see, is this a take-home message that I need to know from this experiment? And in that case, it was. Naphthalene was not extracted because it did not have a benzoic acid or carboxylic acid group. It didn't have an amine group, so it could not be ionized. And by ionization, they mean to be either given an electron or to be given a proton. Either way, ionization is irrelevant towards aromaticity. Aromaticity and resonance are stability structures, and they are not related to the ionization with regards to acids and bases. So so that was pretty much the main tips I wanted to kind of let everyone know, and I will repost this video once again if somebody needs to go back and review through, so that way that one can re-understand anything that maybe, if you feel a little worried about your lab notebooks. Overall, everyone's doing great. I hope you had a good summer, spring break. And let me switch over here to our module. Oh yeah, and make sure if you haven't, I did see a good amount of people have started up on the HOLA chem experiment or like the discussion part. That's great if you've already done it, awesome. If you haven't gone forward to do that yet, please go make sure to do the discussion. I'll keep reminding y'all until that last, very final week. But once again, don't hesitate to complete it until the last minute, just because you don't want to end up rushing it and then getting a low grade on it and it impacting your final score. So yeah, I'll just keep reminding everyone as we keep going. Let's come on over here. And so firstly, today we're going to be doing experiment 8, Sn1, Sn2 reaction. If you check on Canvas in your inbox, make sure to check there, because for some reason the data was locked, and you'll see I sent it in an email or in a Canvas inbox message to everyone in both of my labs that I teach. So firstly, we're going to go through the lab manual like we usually do. And secondly, make sure to watch through these videos. As usual, I'm not going to review these videos because a lot of it is just setting up the experiment. I'm going to kind of walk you through it a little bit here, but it'd be better for you to watch this so that way you understand it. Because if I read out to you, weigh out 0.4 grams of T-butyl chloride, what is that? I mean, it's like, when you read these things and told these things, it's just going to go right over your head and you're just going to accept it and move forward with your life. The reason that we have these videos is so that you can see it, mainly because we're not performing it in real life. And that is a very big part of the lab experience, is having that hands-on experience. So I really, really critically recommend that everyone watch these videos, at your own time. So one video I will show that I took, and I sent it to the other class because this one doesn't show it here, and it's going to be the precipitation to justify that we do have T-butyl chloride, and I'll go forward into that once we get to that section of the lab manual, so that we can once we've created our T-butyl chloride, we can verify in lab almost immediately that we did actually create that through silver nitrate. And I'll review that once we get to that part of the lab manual. So we'll be focusing on Sn1 reaction, which is the creation of T-butyl chloride from T-butanol. And then we'll be focusing on the Sn2 reaction, which is the creation of one bromobutane. I think it's one bromobutane, because we have two videos here. One is one bromopentane, one bromobutane. Both of them are from the alcohol version, one butanol and one pentanol. Either one that you react with sodium bromide will create that. And yeah, so I go forward and make sure that you finished your quizzes, and we will review the data once we get to the end of the lab. Let me check real quick. Okay, so let me see really quick. So I'm a little confused by what you're saying, Nadia, with regards to the procedure. The procedure that you need to write down should just be exactly from the procedure that we'll be performing for the week. And if you're saying that you were confused as to reference as to what week it is, because I know that they created this strangely, just come into here under modules. And then, well, firstly, there's a schedule that is there. Secondly, it's also in the syllabus as to what week we're on. Thirdly, always check the quiz, that'll be there as well. And then fourthly, if you come here, then you can see, well, like, we did our acid base extraction last week. And so this week we'll be doing the Sn1 Sn2 reaction. And next week we'll be doing gas chromatography. So I think that's what it was. Okay. Okay. So you understand. Okay, great. Yeah. So, and yeah, that's just a brief overview as well. If anyone needs any reference towards what we're doing for the week, always come to modules, and then you could just check to see. So for instance, today's the 23rd, March 22nd to 26th. We're going to be doing this experiment today. And let me switch over here to our lab manual. And so I'm going to try and take my time and reiterate the points here a lot today, because the main thing is that this is a very swift explanation. However, in lab, it is not fast, because a lot of the time, sometimes we'll perform these reactions, set them up overnight and come back in the morning. And then because if you think about reaction rate, I'm pretty sure everyone's learned it from like Gen Chem reaction rates. As you give it more time, more energy, more reagent, then the driving force goes forward farther into the product. So more reagents that you add, the more product you get out, the more time, the more heat, the more energy that you put in the system, the more products that you get out, kind of like Le Chatelier's principle. So with this, I'm going to go really in depth into Sn1 and Sn2 chemistry and reiterate points a lot. So it might sound redundant at certain points, but it is just because this would be better to learn in lab by performing these experiments than to just be read it aloud a bunch of times. However, I'm just going to give you as much information as I can so that everyone understands this very well. So firstly, Sn1 versus Sn2. So they're both substitution nucleophilic reactions. Those are the main things. There's a nucleophile and an electrophile involved in both reactions. They're both substitution. And the only thing that's different from them is that one is unimolecular and the other one is bimolecular. So what they mean by that is that the unimolecular route, which is Sn1, is dependent only on one molecule. And that molecule is noted by the slow step. So in an Sn1 reaction, which you may have learned both of these within your organic chemistry class, a tertiary alcohol follows the Sn1 route because a tertiary alcohol makes a very stable carbocation. However, if you look at the other side, a primary alcohol is a very unstable carbocation. It will readily react with anything within a given mixture, and it is not preferred for an Sn1 reaction. Whereas actually a primary alcohol will follow an Sn2 route, and it happens very swiftly. The idea of the bimolecular within an Sn2 is that both the leaving group and the attacking group are counted as in one like slow step. Whereas in the Sn1, the slow step is the leaving group leaving the system, and then the fast step is that attacking group coming in and backside attacking that. So going forward, in the Sn1 reaction, we'll be undergoing it in acidic conditions. And the reason that we're using acidic conditions, as you can see here by the first figure here on 8.1, is that this alcohol group, alcohols, they're very stable. You are ethanol, methanol, all these sorts of alcohols, very stable. So what happens is it's very hard to go forward and actually have a reaction with it, especially whenever that alcohol is it has multiple effects on it. It even has van der Waals effects. It has hydrogen bonding. You know, it has so many effects being attached to this T-butyl group that it is hard to get rid of. So what we do is, under acidic conditions, we can go ahead and protonate this alcohol group. So the electrons, if you think about the Lewis structure, the electrons on the alcohol group will go forward and attack the proton, therefore giving you this OH2. And as we know, H2O is water. Now, water is a good leaving group because it can just dissolve out into our system. So what happens is, this is our slow step. The group is protonated and then leaves, and that takes the most amount of time within the reaction. Once we've created our stable intermediate carbocation, then the fast step occurs, and the chloride go ahead and a backside attacks it, and then we're good to go forward. So mainly the slow step is our acidic protonation of our alcohol group in order to create water. Water is then, it leaves the system, and then we have a stable carbocation, tertiary carbocation, very nice. Then a chlorine comes in and backside attacks it, and then we finally left with our T-butyl chloride. So that is our main idea here. And we won't be analyzing gas chromatography too much this week, but it should be noted that gas chromatography is a way for us to analyze materials. You can analyze your starting material, you can analyze your reactants, you can analyze your product, and they will all give you different varying results, you know, from your gas chromatography experiment. But we'll be covering that more next week in that module. So I want to go ahead and move forward with going into the idea of, oh yeah, right here. This is where I'm going to show everyone the video, so that way that you can get a visual representation of this part. So when you watch the creation of T-butyl chloride video, then you can go forward to see how exactly this is performed in lab, all of the, you know, the steps and the actual, you know, real life action of it, not just writing out a procedure. But the video I'm going to show you here shortly is the conformation of your product, which is T-butyl chloride. So it can be performed by reacting the product with a solution of silver nitrate and ethanol. And then the tertiary alkyl halide, and when they say tertiary, that means the tertiary group here. Alkyl halide is the chlorine is a halide, so that is our alkyl halide. The tertiary alkyl halide will react by means of an Sn1 mechanism with the silver nitrate to form an insoluble silver halide. So in this case, our halide is chlorine. We would create silver chloride, which is insoluble in ethanol mixed with our T-butyl chloride. So let me switch my share screen and open up that video for everyone here, because I'm thinking that it is not attached into the videos that were listed on our module. So let me pull this up, one moment. Okay. And let's switch this. Okay. All right. So firstly, here on the far right, we're going to have our product from the reaction. In the middle, we're going to have a reference sample of T-butyl chloride that is purchased reagent, you know, from a chemical supply store. And then on the left, we'll have water. So water, it can dissolve the silver nitrate. That's fine. The middle is a reference because, you know, it's pure. And then the right side is the product from the lab. So firstly, we add here the water, just normal water. And then secondly, we would take our T-butyl chloride. I'm going to have to skip forward into this video as well, because this sample of T-butyl chloride that they used for this was tainted. It probably just decomposed, maybe reacted with water and reformed the you know, T-butanol in the air. That is one thing in lab. If you don't have things in under anhydrous conditions, they can actually hydrolyze. So maybe the T-butyl chloride went back to the T-butanol. So primarily here, we'll get close to the silver. So here's the silver nitrate. And we put it into water, then you can see that nothing happens. You would expect this second one to react. However, you know, they had a tainted reagent. So I'm going to skip forward in the video after this. But then in the third one, you can see it starts to get cloudy almost immediately. And I'm going to shake it around. So the third one, that's the product, like what we made in lab, like fresh T-butyl chloride. And you can see immediately it's already cloudy. And then let me skip ahead for you because they had to go get like an actual new bottle. It's not the best reference since they messed up in the first part, but this is a good pure bottle of T-butyl chloride, just so that they can show you throughout this whole video, they performed the synthesis of it in lab, but this is also the reagent that they purchased, you know, from whatever chemical store that they purchased it from. Okay, so then the T-butyl chloride, the pure sample, is in the test tube. And now we'll take the silver nitrate. And upon addition, you see it gets a little cloudy. And then they swirl it around. I'll give it a second because she kind of has it up against the white wall. And then there you can see now it's a milky precipitate just like the other. And then the water, even after all this time, nothing happened. So the left one, water, nothing happens. The middle one, pure T-butyl chloride, reacts in the Sn1 mechanism just the same way, creates the silver chloride insoluble. And then the final one as well is the product that we would have created in lab, which would also be presumably pure T-butyl chloride. So that's what I wanted to show there. And there is another example that I was trying to find and I just couldn't find it today. But I'll still try and look that everyone can see for our Sn2 reaction, because there is another form of test that we can perform on our product. But let's keep moving forward into the Sn2 reaction now that we've completed the Sn1 understanding of it. There's a slow step, the acidification of our hydroxyl group to create water. Water is given off, and then a chlorine group backside attacks and it creates T-butyl chloride. So going forward, we're going to learn about the conversion of 1-butanol into 1-bromobutane by an Sn2 mechanism. So when we talk about this again, the bimolecular action, just remember, simultaneously the bromine coming in and the hydroxyl group leaving is bimolecular. It depends on both of their rates leaving at the exact same time. It is one small reaction curve. Whereas if you looked at the reaction diagram of an Sn1 reaction, it would be a big slow step, and then at the very bottom, a small fast step. So the Sn2 reaction for converting 1-butanol or any sort of alcohol into an alkyl halide would be, firstly, you have your primary alcohol. So we remember primary alcohols, not very good carbocations, but they're very readily attacked in Sn2 fashion by a halide, such as the bromine here. So we would use sodium bromide, react it, maybe add a little bit of heat. What happens is whenever you see things in the brackets, and this is a review because I'm sure that everyone knows this, but if it's in the brackets, it means that it's an intermediate step. And so it's a fast intermediary step where it immediately, the bromine comes in and the hydroxyl group leaves. So this is not a middle ground of saying that it's going to be, okay, it's here and it's sitting and then the hydroxyl group leaves. It is at the same time the bromine comes in, the hydroxyl group is leaving. So this intermediate is just to show you a visualization of it. But within lab, if we were to perform this, the bromine would come in and the hydroxyl group would leave immediately. So going forward, conformation for your product of 1-bromobutane can also be performed by reacting the product with a solution of sodium iodide. So within the same fashion that the silver nitrate came in and created silver chloride, which is insoluble, sodium iodide can come in. It is a stronger nucleophile than bromine. So what would happen is the exact same thing would happen here. It would come in and the iodide would come in, and then simultaneously, boom, the bromine leaves. So it's an Sn2. You have to remember it as very fast. It comes in and goes. Sn1, something comes in, attaches to our leaving group. The leaving group goes. Now we have this intermediate carbocation, and then our attacking group comes in and attaches. Whereas in Sn2, our attacking group comes in and our leaving group goes out. It's just one full flowed step. So I will try and find a video so that I can show everyone a sodium iodide reaction. I tried performing it in the lab, but I didn't have a bromobutane. I had a bromodecane, and I think just because it needed more, it just needed more of a driving force into it. It didn't immediately perform the precipitation that I wanted it to. So I'm going to try and find a video that everyone can see just for a visual representation of it performing or creating an insoluble precipitate. So see, this is pretty much the end of the lesson here. I'm just going to briefly go through and show everyone exactly what we'd be performing in lab. So in the Sn1 synthesis of tert-butyl chloride, We would be synthesizing T-butyl chloride. We confirm it using the silver nitrate test to create silver chloride, which would be insoluble in precipitate. And then we would finally verify the product by using gas chromatography. So if you need to find what the size of the glassware is, read through here very carefully and you'll see all of them. 50 milliliter Erlenmeyer, graduated cylinder, I would say as well, 50 milliliters. As long as you give me something reasonable, I'm not going to be nitpicky on if you used a 25 milliliter graduated cylinder for 15 milliliters of HCl, or 50, maybe even 100. But if you said like a liter graduated cylinder, that's not going to work. Just give a very roundabout idea. If you don't have a specific idea of how big these items should be, then you just give it within the range. So 50 milliliter Erlenmeyer. Going forward, it goes and stirs, and then we go forward and it reacts. Then we go and use our separatory funnel. If you are draining the lower aqueous layer into 125 Erlenmeyer, you could assume that your separatory funnel would be at least 125 milliliters. So, it's kind of these assumptions we might have to make. And it is unfortunate that it's not listed out clearly for everyone. But, use your critical thinking. Y'all have done great so far on the glassware. So I want to make sure that we keep going forward with ideas of the sizes that we might need to use for this. And so then once we've actually gone through and forward, we would dry it. And then we would weigh and clean a dry 10 milliliter vial in order to weigh out our final product. And then we would prepare the gas chromatography. So one thing that we'd be utilizing here would be stir plate would be our machine. The Vernier mini gas chromatography machine would be a machine. LabQuest would be a machine. Let's see, going forward. So I don't personally have a video here to show for it, but this is exactly the diagram of what a gas chromatography machine looks. It's a small table side, bench side machine. You take your sample into it, you inject it, runs it through. We attach a USB to a printer, and we can print out the data so that way you can analyze your graph. So going forward, then we set up our silver nitrate test, just like the video I showed you. Distilled water, pure T-butyl chloride, and then your product. And so you would add your silver nitrate into each solution, and then you would see the precipitate from both of the last two. Okay, let me see real quick. I have a little check. So let me check really quick if there's a heating mantle within this one. So you put hydrochloric acid into an ice bath, into a, so let's see. So I think within this one, we're just using a stir plate. So one thing is that you can say stir plate. There are two things in lab, and this is why I wish that we could be in person for this, because a heating mantle is an object itself, but a stir plate can also have heating functions on it. So if you just put stir plate, that'll count for me. In this situation, we would be adding cooled acid into a flask and then stirring the flask, putting on the stir plate in a medium stir, and then that's it. So this would not require a heating mantle per se. I would say to go forward with a stir plate with regards to this, since we are performing this under cold conditions and then at room temperature. And then the gas chromatography machine as well. And let's see. So yeah, then we do our silver nitrate test, like I showed the video for everyone. And then the data tables, we'll review the data here after we get through this next portion. So this data analysis portion, you could either put the data analysis within your data section, or you could put it in the post-lab. These are considered the post-lab questions for this, this experiment. So wherever you want to format it, because I did see some people put conclusions before the post-lab, some people put them after. I don't take points off for that. As long as both of them are there, you're good to go. So then next, Sn2 reaction, synthesis of 1-bromobutane. You'll synthesize your 1-bromobutane by the Sn2 reaction. Secondly, you would utilize the sodium iodide in order to confirm that you have brominated your 1-butanol. And then thirdly, you would verify your product by using gas chromatography. So you would take a test tube here, put a boiling stone in it, and these are all apparatus. So, you know, start making lists of all these things. Then your sodium bromide, make sure that's in your hazards. You put it in there. You put one milliliter, just a couple drops of water. You'd add 2 milliliters of 1-butanol. So you have your alcohol, your sodium bromide is going to react with it. Prepare an ice water bath using the 250 milliliter beaker. So I had that there. Then slowly you add in concentrated sulfuric acid. You use acid as the driving force within this system as a catalyst in order to acidify the system. And so then you would clamp test tube to a ring stand. So have your ring stand listed, have a sand bath listed. Oh yeah, so actually here it does have a heating mantle. So do go forward to add a heating mantle, or if you wanted to even say stir plate with heating function, I will not count off points for either, so long as you have a heating function. So the first reaction, the Sn1 reaction, looks like you don't need heat, but it does look like here that you would need heat in order to perform the Sn2 reaction, because you'll heat it to a boil. Reflux, which just means to kind of like when you're on the stove and you're boiling water and you cover it so that way the water doesn't evaporate, that's like refluxing. So once your reflux is complete, remove the test tube, then you remove the lower acid layer using a Pasteur pipette, and that way you're pulling out your sulfuric acid. You're just left there with your 1-bromobutane. You wash your bromobutane with water to remove any of the excess acid and other sort of aqueous waste that is in from your reaction. And finally, you would wash with sodium bicarb. Go forward, use saturated sodium chloride to dry out your solution. And then finally, we go into the analysis of the gas chromatography. We would take our 1-butanol and our 1-bromobutane. We would run them through our gas chromatography machine, print out our results. And so, yeah, just make sure, you know, you really study through, read through this very well, create a really nice lab notebook for this, because this is a long lab. If we were in lab, we would have been in for 3 hours. So I just want to make sure y'all try really hard on this one, because, you know, we're kind of just breezing through 2 really longer experiments, and also the use of the gas chromatography machine. So please do review the videos, you know, at your earliest leisure. Then going forward, the sodium iodide test. So you set up a hot water bath. Then you obtain the 3 test tubes. You get your distilled water, your 1-bromobutane, and then the product that you created. Add approximately 1 milliliter of 15% sodium iodide and acetone solution to each test tube. So you would measure out for 1 milliliter, you would have 0.15 gram of sodium iodide dissolved into your acetone. You would swirl all the test tubes, and then you would see the precipitate in the 1-bromobutane test tube number 2 and your test tube number 3 with your product, which is the 1-bromobutane. Okay, let me check real quick. Yeah, so in the hazard section, then we want to make sure in the hazard section, it's all chemicals that we use. If you've added, you know, too many chemicals, that's fine. Better more than less, just because, especially like in this one, we do have a lot. We have 1-bromobutane, we have 1-butanol, we have sulfuric acid, we have sodium iodide, we have sodium bromide. You know, there's a lot in this experiment specifically. So yeah, just make sure to add every chemical you see on there, every one that you see, more the merrier, safe than sorry in this case. Will a cool water bath and a hot water bath be in there? So the cool water bath is an ambiguous thing, because when we create a cool water bath, we can either use a beaker or an actual bowl. And so if you just put 250 milliliter beaker, that would be good for me for the cool water bath, because we would just be using a little test tube. We're not creating like an actual like big ice bath for a big reaction. We're just making a very small test tube reaction. So going forward, then once again, we have our data table and our observations with what happens here. And this is important to go forward and think about what would happen with regards to our solubility at room temperature versus 50 degrees Celsius. And this is the critical thinking part that everyone needs to do whenever you're at home, and start to understand what's the reason that we have different observations at room temperature than at 50 degrees Celsius. So finally, you have your data analysis section, and make sure to go forward and complete that either in your data section or your post-lab question section. And make sure, big thing too, Everyone did really well in the the experiment where we had two portions. I think it was the polarimetry. And in this case, we do have two experiments. You can either combine them or put them separately, whichever way that you want to, but you have to have both procedures. If you only have the Sn1 procedure, then you're only going to get half credit. If you only have the Sn2 procedure, you're only going to get half credit. It's the same thing I keep saying over and over. You need to be able to walk into a lab and perform both of these experiments in this case, only utilizing your lab notebook. So, okay, can I explain the observation section in our data sheet? Yeah, so I'm gonna pull the data sheet up here in just a second, and then we can analyze that. And do we have to put however many glassware? Yes, so I'm not gonna be too hypercritical on exactly if, there's 10 test tubes, there's 2 test tubes, there's 20, 100, just, give a roundabout from what you see from the procedure. And if the glassware, the main thing I want everyone to understand is the sizes of the glassware that we're going to use. So if maybe you have 1 or 2 missing, maybe we had 3 test tubes, but you put 4 test tubes, I'm not going to take points off for that. It just needs to be known the sizes of these apparatus that we're using. So let me go ahead and pull up because I understand what question is being asked, and I'm going to try to avoid answering exactly that question because it is a data analysis question and I'm not allowed to, just give you flat out answers. What I can say regarding this, because I know the question you're trying to ask, because it's this part here. So the observations at room temperature versus our observations at 50 degrees Celsius, I would say to review up here and see from our procedure what happened whenever we performed the Sn1 reaction versus the Sn2 reaction. Did we have heat in the Sn1 reaction? And did we have heat in the Sn2 reaction? And then think about solubility. Solubility is much different if we remember from recrystallization. At high temperatures, solubility is very easy for many molecules. But when we lower the temperature, then things can fall out of solution. So go forward and review the procedure. I also recommend highly to watch the videos that are presented on the module, so that way that I don't explicitly just give answers out, especially during the Zoom call. So let me go forward and pull up our data set so we can review the data that we are given here. And the main thing is that I want to lead everyone in the direction of understanding these concepts without explicitly giving you, the homework answers, just because that would mean that, there was no action taken outside of the lab, especially that once we're done here on the Zoom call, that's, pretty much it. And then once I show everyone the data here, then we'll be done. So let me open up our data here and check your inbox on Canvas if you have not downloaded your data yet. So let me share my screen once more. Okay, so if your name starts with, hold on one moment. If your name starts with A to M, then we're going to analyze the data sent to you. There's only 2 files, A through M for your first name, and then N through Z for your first name. So if your name starts with A to M, here's your data. In the post-lab calculations, make sure to write down or type out your calculations of the product. Then go forward, pull all this data into your document. For the Sn2 reaction, same thing here. So they did give you the observations at room temperature with regards to the coloration that you'd see. So then you have to go forward and have an analysis. Look through your procedure, watch the videos that we gave you in the module, and then you'll understand exactly how what the observation should be at 50 degrees Celsius. And also when they say clear, they mean that it is permeable. You can look through it. You can have a clear solution that is yellow, but when they say clear, they mean that you can actually just see through something. You can have a clear yellow solution and be able to see through it, but the color is yellow. So that is one observation in chemistry. And then if you have the N through Z first name, then here's your data. Once again, make sure to do post-lab calculations here. And finally, report your observations in regards to here. And the data analysis sections in the lab manual are the post-lab questions. So make sure to finish those. Seems like everyone's doing pretty well with understanding all of the post-lab questions. So I'm going to go ahead and wrap it up here and pause.